Imagine for a moment that you're behind the wheel of a car, speeding down a highway at 100 kilometers per hour. The wind rushes past, the road blurs beneath the tires, and there's a sense of exhilarating momentum. Now, picture another car approaching from the opposite direction at 120 kilometers per hour. At first, the difference between your speeds doesn't seem so significant, until the instant you realize that you're heading directly toward each other. The closing distance shrinks alarmingly fast, and the true force of your combined velocities becomes clear. This accelerating approach, this sudden convergence, isn't just a trick of perspective. It's a fundamental principle of motion. And while it's dramatic enough on a highway, in the vastness of space, these rules become even more intriguing, shaped by forces and influences far beyond our everyday experience. In space, everything moves at astonishing speeds, but those speeds only make sense when we consider them in relation to something else. This is the principle of relative velocity. It's not enough to know how fast a spacecraft, an asteroid, or a planet is moving in absolute terms. We need to measure that speed against a reference point: Earth, the Sun, or even another spacecraft. Imagine a hypothetical object called Atlas traveling at 260 kilometers per second. That number alone is breathtaking, but its true significance lies in its direction relative to us. If Atlas and Earth are moving toward each other, their speeds combine and the approach is rapid and dramatic. If they're moving in the same direction, the closing speed is much less. And if their paths cross at an angle, the velocities must be calculated along that specific trajectory. In the cosmic dance, perspective is everything. Now, think about what happens when a spacecraft leaves Earth. It doesn't simply break free and drift away untethered. Instead, it remains under the influence of Earth's gravity, an invisible, persistent force that acts like a long, elastic cord, tugging the spacecraft back toward its home planet. This gravitational grip loosens as the spacecraft travels farther away, but it never truly disappears until the craft is well beyond the sphere of influence that defines Earth's gravitational reach. Only then does another force, perhaps the gravity of the Sun, begin to dominate, and the spacecraft must adjust to a new center of attraction. Just as a child throws a ball upward and gravity eventually pulls it back down, a spacecraft needs enough energy to overcome this invisible leash. If it doesn't reach escape velocity, about 11.2 kilometers per second from the surface, it will inevitably return, drawn home by the planet's persistent embrace. But even above this speed, the spacecraft continues to interact with Earth, the Sun, and other massive bodies, each exerting their own subtle pulls. Let's use a nautical analogy. Picture a massive ocean liner and a tiny sailboat crossing the same stretch of open sea. From the perspective of the ocean liner, the sailboat seems to bob and sway unpredictably with each passing wave. But from the point of view of the sailboat, it's the giant ship that appears to surge through the water with imposing, almost unstoppable force. This shifting perspective is echoed in the cosmos. Celestial bodies of vastly different masses, planets, asteroids, spacecraft, respond in unique ways to the energies and forces that swirl through the universe. The rules that govern their motions are universal, but the ways they react can differ dramatically depending on their mass, composition, and the nature of the forces at play. This opens up an intriguing possibility. What if some objects in the universe behave differently from others, not because the laws of physics are being violated, but because they're responding to distinct influences? Their motion could be shaped not only by gravity and inertia, but also by their own inherent properties: density, composition, even their internal structure. Imagine streams of gravitational currents, vast interstellar magnetic fields, or elusive flows of dark matter, each affecting celestial bodies in subtle and unique ways. Two objects traveling through seemingly the same region of space might, in reality, be navigating entirely different energetic environments, shaped by forces that remain invisible to us. Consider again the scenario of two objects racing toward each other in space. If Earth were moving at 108,000 kilometers per second toward an incoming object traveling at 216,000 kilometers per second, you might expect the combined approach speed to be a simple sum of their velocities. But in reality, the answer is more nuanced, depending on the chosen frame of reference. If we add to this the possibility of hidden influences, magnetic fields, gravitational anomalies, or variations in dark matter density, it becomes clear that two objects, even on apparent collision courses, may in fact be traversing entirely different cosmic seas. Among these hidden forces, magnetic fields play a particularly fascinating role. Unlike gravity, which always attracts, magnetic fields can both attract and repel. They can serve as invisible locks, holding vast regions of space in relative stasis and keeping celestial bodies at stable distances for eons. These magnetic fields aren't limited to the poles of planets. They can stretch for thousands of kilometers, interacting with other magnetic sources and subtly altering trajectories. Over time, these interactions can adjust the paths of planets, asteroids, and comets, sometimes preventing what might otherwise be catastrophic collisions. Imagine if these repulsive magnetic forces acted as cosmic shields, gently steering wandering bodies away from planets and moons long before an impact becomes likely. This would mean that the solar system's natural balance is maintained in part through these quiet, almost undetectable interactions. Dangerous trajectories might be nudged, curved, or softened, protecting worlds from devastation in ways we scarcely perceive. The universe, then, is not just an arena of blind chance and collision, but a realm where invisible hands are constantly at work, shaping the destinies of worlds. This perspective fundamentally shifts our understanding of motion in the universe. Instead of seeing movement as the simple result of gravity and inertia, we begin to recognize it as a dance within an invisible ocean of forces. Every celestial body, from the smallest asteroid to the mightiest planet, is shaped by its own unique interaction with these currents, sometimes amplifying their effects, sometimes dampening them. Even minor differences in mass, composition, or structure can lead to unexpected behaviors, causing some objects to follow predictable paths while others seem to defy the norm. So, when we analyze cosmic encounters, like a spacecraft approaching an interstellar object or two planets passing within close range, we must look beyond the obvious factors of direction, gravitational pull, and relative velocity. We need to consider the possibility that layers of unseen influence are at work, shaping the outcome in ways we are only beginning to understand. This could explain why certain objects appear to break the rules, moving in ways that surprise and challenge our expectations. Space, then, is not an empty void, but a turbulent sea stirred by invisible currents and hidden energies. Every planet, moon, and wandering rock sails through this ocean according to its own nature, buffeted and guided by forces we are only just beginning to detect. The question remains, have we truly uncovered all these cosmic currents, or are we still skimming the surface, unaware of the deep, powerful flows that shape the universe's grand design? As we continue to explore, to send our probes and telescopes farther into the unknown, we peel back the layers of this cosmic mystery, discovering new forces and influences with every step. The journey is far from over. The more we learn, the more we realize how much remains hidden, how many secrets the universe still holds. Each new discovery changes the map of the cosmic ocean, guiding us toward a deeper understanding of the forces that shape everything, from the paths of distant comets to the fate of entire worlds. So, as we set sail through the stars, let's remember, every journey is shaped not just by the visible, but by the hidden. The universe is a place of wonder, where invisible tides carry us ever onward, and where every traveler, no matter how small, has a role to play in the grand voyage of existence.